Today on the bench we have a Cobra 148F GTL. This one's in pretty good condition. Customer brought this in. Basically the only thing he wanted done to this was have the Channel King modification board installed. It did have a channel modification originally on the dim and tone switches, so those have been put back to original. But as you can see, and this is the perfect radio to put this board in, because it has the built-in frequency counter. So you don't have to, guess, oh, what the heck channel is number, 62. Well, it's right there on the frequency counter. Probably honestly, the two best radios to put one of these boards in would be either the 148F GTL or the Cobra 2000. Now, one interesting thing I did discover with the 148F GTL is, honestly, I think it does a better job than, as far as broadbanding goes, than the 2000 or a normal 148. So I've installed these boards in Cobra 148 GTLs and Cobra 2000s, which they both share the same circuit board. This radio, however, does not. This radio has a EPT 014813Z board in it, so it's got a Ranger circuit board in it. It's not the normal Uniden circuit board. And there are a few changes throughout that you can notice here and there. I mean, it's pretty much overall. I'll show you. I've only got the cover setting on it at the moment. I'll actually show you what it looks like inside. I mean, it looks like a normal 148 board, but there are some minor variations. And apparently those minor variations make a lot of difference, because the 148s and the 2000s, they had a hard time getting lower channels, so down below channel 1, and your high end, it would start to drop off long before it does in one of these. The other thing that I noticed was, no matter where you center tune this in the CB band, so I actually tuned this one on channel 40. I moved the center tuning point up a little bit. But one thing I noticed was, if you put it on, didn't matter, channel 1, 19, 40, wherever you center tune, when you do the alignment, the receive sensitivity still gets better the higher you go in channels. So this radio from, let's say a factory alignment, it's center tuned on channel 19. Actually, the first thing I noticed was, when I installed the Channel King board, any other radio, when you install that, the VCO will not lock in it. You have to adjust it to get it to lock on any channel, because the VCO range is completely different than it is with just a factory PLL in there. This radio locked. I installed the board. When I first turned it on, and the VCO core had never been adjusted. Still had the wax in the center of it. And it locked from channel minus 60 to, God, I think it was close to 200. Just the tiniest bit of adjustment, I was able to get it to lock up to 292. So, yeah, it has a surprising difference. There's differences there. Obviously, the VCO block in this is a Ranger VCO block. It is not the old Uniden style that were epoxy dipped. This one just has like a black conformal coating on it. But like I say, so there's definitely a difference in the VCO block, and also that allows this radio more range than the other ones that I've installed. The other ones, you can get to 200 and the low 200s, I think it was. And as far as the low channels go, it would only lock like from, say, 35 to 40, somewhere in that range. In other words, minus 35 to minus 40. This one, it locks at the lowest possible channel, minus 60. You can see there's the frequency counter. So you can, actually, I got the clarifiers off a little bit. Here, let me get it recentered. So you can see it's locked, because if it's not locked, the frequency counter it'll display a bunch of gibberish, because the VCOs, it's not locked onto the PLL. So, I'm going to go the other way. So you can see it locks from channel 290, which is 29.905, all the way to channel minus 60, which is 26.365. So it has a phenomenal amount of range. You're looking at what, like 3.5 megahertz? Yeah, because that's what, Yeah, 350. Yeah, that's 350 channels. So 290 plus 60. Granted that's minus, but that's 60 channels below and 200 above, or 290 positive channels. So 350 channels at 10 kilohertz spacing is 3.5 megahertz. That is an amazing range for that VCO to lock. But then again, it's a Ranger VCO block, and they make broadband, export radios. So I guess that's kind of almost to be expected a little bit. I actually need to tinker around with some of the Ranger IF cans and some of the tuning transformers, putting them into a normal 148 to see if I can increase because the receiver and transmit is also broader. Now don't get me wrong, at channel minus 60 it's fairly good, but at channel 290, yeah, you might as well hang it up, just because this radio is locked on that frequency. Yeah, your output power and receive sensitivity is so ridiculously low, it's not even usable. But this one's, I don't think the power actually starts to drop off at all until it was, like 100 and, there's an easy way to find out. And this is a 5-pin, so I need my adapter. Let me just grab a microphone. And make sure I'm on dummy load. We'll just see. I'm going to go back to the home channel, 19, and just key the radio. Actually, let me turn the microphone volume down. And I'm just going to start spinning the knob. Okay, so right around the hundreds where you start to see the power drop off. And it just gradually tapers off. Now this radio, you'll notice the needle's down rather far. This radio had the dead key set at 2 watts, and that's what the customer wants it at, so that's what I have it readjusted for. So, your output power is going to drop to really non-usable range faster because the output power is adjusted so low on this to start with. But, there's still power, my meter just over there, it trips with a relay from receive to transmit. It starts to knock off, but you can see the needles still going down. And then actually you see once we get to minus 60, you can see the power's back up. But like I say, it's just surprising how likely. That's just because the carrier is adjusted at 2 watts on this. It's going to drop down to, basically non-usable power level a lot faster than it would in a normally adjusted radio that's set for a 4-watt dead key. But so let me get the covers popped off so you can just take a look at the installation real quick. Okay, and here's the interior. Now, the one thing that makes it kind of a little tricky in one of these radios is you want to try and keep this module, for starters. Ideally, you want to keep it as close to the display as you can. You can go a long way away, but ideally you want to try and keep it close because this cable is noisy. That's why wrap RF shielding tape around it for starters, because you don't want to introduce a bunch of noise into your receiver. But of course, this is a F model radio. So this has the frequency counter module, which normally goes right here in that hole right there and hangs out about to here, because it's normally mounted in this orientation. So I had to get a little creative. I just swung it around. I have a bracket and everything, some standoffs, and it's now mounted in the center of the board. The cable length worked out. It was long enough to where I was safely able to just basically dismount it and twist it around. Had to, cut a few wire ties, reposition them, and then tie everything back up. But and then install the channel board. But yeah, there are some differences in this radio. Like I say, I really need to investigate that a little bit more. It's a customer's radio. I'm not going to go just pulling parts out and completely dismantling it to reverse engineer it. So I need to dismantle one of these, and my own, and see exactly what the differences are. I need to, because all the transformers in this, they have Ranger, Galaxy part numbers on them. So they don't use, like in a Uniden built radio, all of the part numbers would start with LA, like LA 216 or 264 or something like that would be the part numbers. All the part numbers of all these transformers are, what are they, like 5-digit codes. They start out 1, 2, and then 3 more digits. So, you know, they might have a better Q factor and a different permeability cores. Now, they're supposed to be direct swaps in for the earlier LA version transformers, but I'm wondering if that's part of what allows the receiver and transmit to broadband a little bit better, is the Q factor and the permeability of the cores is a little bit different than in the original Taco Trans, because these are Taco transformers, still made by the same company. They just have a different part number, so that's one thing. Like I say, the other thing, obviously you can't see it, the channel board's on here, but the VCO block, it's not one of those kind of reddish-brown dipped VCO blocks. It looks like if you take the cover off of a Ranger radio, if you're familiar with looking at them, they're just black with a bunch of surface mount components on it, and they dip it in like a black conformal coating. But you can see the parts through the conformal coating very clearly because it's very thin. I think that and maybe the VCO core that they have in this are what give the VCO such a large range. But, yep, so, but like I say, this actually turned out to broadband a lot better than anything else I've stuck one of these boards in, and it works really well. So, you know, there you go. And if you ever install one of these, like I say, you can see how I installed it in the F. I did move the frequency counter, because, you know, with this module over here, the only other real mounting location could have stuck this would have been over here. Then you'd have to deal with all of these wiring harnesses, and yeah, it'd have been a nightmare. Just so much easier just to shift the frequency counter module around 90 degrees, mount this to its 2 tabs that are, you know, designed specifically for this chassis, basically. You know, that's the whole spacing on these was designed to work on this style of radio, the 148 chassis. So, you know, it's the perfect place for it. So that's why I wanted to move this module over. I might, and I think I'm still going to do it, even though I have, there's plenty of support there. And this radio is, honestly, it's going to be used as a base radio for this customer. Actually, even has, he already has rubber feet on the bottom of it. But I think I might, now that I'm done with it, it's ready to be buttoned up, I may run a heavy gauge solid copper wire, like a piece of 12 gauge wire, from these transformer cans up to the back of this housing, just to give the rear of this a little bit more support, so it's you know, mounted at the front down into the faceplate, and then, or, you know, the faceplate bracket, and then from here down to here to make it a good solid mount, just in case in the future the radio gets sold and it gets used in a mobile application. I mean, yeah, I could just mount a piece of foam on there, but I'd rather do it proper and have a good mechanical fastening. So, but there you go. There's another Channel King, and this will be, I guess, number 3. This should be the third one, you know, the third public released radio with this channel board in it. So, there you go.